All right, today we're going to talk about something really fascinating. It's a treatment for skin cancer, a cream that doesn't actually attack the cancer itself. Instead, it teaches your very own body how to destroy it. So, how in the world does that work? Let's dive in. Okay, so this really does sound like a riddle, doesn't it? We're talking about basal cell carcinoma, or BCC, the most common type of skin cancer. And this cream, Imiquimod, works wonders on a certain kind of it. But here's the twist. The drug itself isn't toxic to the cancer. It doesn't poison the tumor cells or kill them directly. So, if the cream isn't the killer, what on earth is going on?
Well, the answer is just, it's so elegant and it's incredibly powerful. Instead of being the weapon itself, the cream acts more like a drill sergeant. It gets in there and completely reprograms your local immune system, turning your own cells into a highly trained, highly effective, cancer-fighting army. So how does this actually work? How can a cream just flip a switch inside our immune system? Well, it turns out it all starts by hitting one very, very specific button.
That button has a name, toll-like receptor 7, or TLR7 for short. And the best way to think about it, it's literally like an alarm switch for your immune system. It just sits there on some of your most important immune cells. And when a mimic comes along and flips that switch, it kicks off this massive coordinated defense. Now here's where it gets really interesting. Who actually has this TLR7 alarm switch? Well, a whole bunch of our immune defenders do. Your dendritic cells, macrophages, you name it. But, and this is the absolute key to the whole thing, the cancer cells? The basal cell carcinoma cells themselves? Nope, they don't have this receptor. The drug isn't even talking to the cancer. It's whispering in the ear of your immune system, telling it where the bad guys are. So once Imiquimod hits that TLR7 receptor on an immune cell, bam, it sets off this incredible chain reaction inside the cell. It activates a pathway that gets these key molecules, these little molecular managers, to wake up. Think of them like foremen in a factory. They march right over to the cell's DNA and start shouting orders. And what are they ordering? The production of a whole suite of powerful pro-inflammatory anti-tumor genes. Okay, the factory is now humming. Those anti-tumor genes have been switched on. So what happens next? Well, they start broadcasting. And this leads to something we call the cytokine cascade. Yeah, so these genes start pumping out these little signaling molecules called cytokines. And you can just imagine this as the immune system's version of an all-points bulletin going out over the radio. These signals, things like interferon alpha and TNF alpha, flood the area, basically screaming, "Hey, we've got a major problem over here. Everybody get here, now!" And this isn't just random noise. The specific mix of cytokines is so important. It creates a very specific kind of alarm. It shifts the whole environment, the whole battlefield, into what scientists call a Th1 dominant state. What does that mean for us? Basically, it changes the rules of engagement from, just keep an eye on things to seek and destroy. It creates this super aggressive anti-tumor environment. So the alarm is blaring, the battle plan is in place, now it's time to call in the cavalry. This is where we get to see the cellular army really come to life. And wow, what an army it is. First, you've got your plasmacytoid dendritic cells. They're like little interferon factories, just amplifying that alarm signal, making it louder and louder. Then you have your natural killer cells. They're the first responders, the SWAT team kicking down the door. And then you get the specialists, the cytotoxic T lymphocytes, or CTLs. These are your elite assassins, specifically trained to hunt down and destroy those BCC tumor cells. And this is the end game. All of these different types of immune cells just swarm the area where the skin cancer is. They create this dense wall of defenders. They surround the tumor cells and basically tell them, all right, your time is up. They force them into what's called apoptosis, which is just a fancy term for programmed cell death, a clean, neat self-destruction. The immune system, now fully awake and angry, just takes the tumor apart piece by piece. Okay, so the mechanism is incredible, right? But you might be wondering, why does it work so well for one specific kind of skin cancer, superficial BCC, but not so much for the others? Well, it really just comes down to logistics. Think about it. With superficial BCC, the tumor is right there at the surface. It's thin, the cream can soak in easily, and when the immune army shows up, they have a clear shot at the target. But for those deeper types, it's a whole different story. The cream can't penetrate deep enough, and the tumor itself can be built like a fortress, with fibrous walls that physically block our immune cells from getting in.
But wait, there's one more piece to this that's just so cool. Maybe the most important part long term. Because this whole process uses your own immune system. It's not just about destroying the tumor that's there right now. It's about creating a memory. See, if you just cut out a tumor, fine, it's gone, but your body doesn't really learn anything. With this method, the T cells that figured out how to kill the cancer, they stick around. They become like little sentinels, patrolling the area, which could mean a much lower chance of the cancer ever coming back in that spot.
All right, let's wrap this all up. Let's pull all these pieces together and look at the big picture. You know, there's a quote from one of the scientific papers that just nails it perfectly. It says, Imiquimod converts a relatively immune-evasive microenvironment into an acutely inflamed cytotoxic immune battlefield that eradicates superficial BCC. A cytotoxic immune battlefield. I mean, that just says it all, doesn't it? So if you take away one thing, let it be this. This cream isn't a poison. It's not chemo. It's something way, way smarter. It's an immune reprogramming agent. It doesn't kill the cancer. It teaches your body how to be its own cure. And that really leaves you thinking, doesn't it? This whole idea of not attacking a disease directly, but instead teaching and redirecting our own body's incredible power, it's one of the most exciting things happening in medicine today. So if we can teach our immune system to beat a common skin cancer with just a cream, what's next? What else can we teach it to fight?